Let's look at final exam question number 15. That is found on page 664 of Teach Yourself Electricity and Electronics, 5th edition. That's edition number 5. We're told about a circuit that has a dozen light bulbs, all identical. All of these are identical. These little circles are bulbs. That's the battery, 12 volts. 100 milliamperes is the current flowing through this circuit. Now let's say that these are pretty robust bulbs and they can tolerate a little bit more. Each one of these bulbs, by the way, is getting 1 volt because the voltage divides up equally among them, and they're 12 volts and 12 bulbs. 1 volt across each one of those bulbs. Now let's suppose that we short one of them out. Doesn't matter which one. How much current is going to be flowing through this circuit now? Well, this is a little bit tricky, but if you think about it, you've got 1 volt across each one of these bulbs and 100 milliamperes flowing through each one of these bulbs. So the resistance of each bulb is the voltage across it, which is 1, divided by the current through it, which is 0.100 amps. Or, so each bulb has 1 divided by 0.1 ohms, or 10 ohms of resistance. Now that's not going to change. If we short out one of the bulbs, the other ones, let's just assume that they continue to have 10 ohms of resistance. In real life though, bulbs vary a little bit in their resistance if you change the voltage across them or the current through them. But let's, for simplicity, suppose that they remain at 10 ohms. Now instead we have 11 bulbs in series in effect rather than 12. So we have a total resistance of 11 times 10 ohms, or 110 ohms. We have 12 volts. Now we can calculate the current. I equals E over R. Equals 12 volts divided by the resistance, the total resistance, 110 ohms. And if you use your calculator, you'll find out that that comes out to just about 109 milliamperes. That is choice B, as in Bravo. A little messy, but not too bad.